Salut à tous et bienvenue sur Bikers HQ. Aujourd'hui, je vous présente un épisode un petit peu spécial parce que pour une fois, je ne vais pas le faire tout seul, je vais le faire avec Julien. Alors Julien, c'est un étudiant de l'université de Lausanne, tu es étudiant en sport et puis tu m'as contacté par rapport à ton travail de bachelor que tu voulais faire au sujet de l'évolution des technologies en MotoGP. Alors comme moi, je n'étais pas vraiment qualifié pour te répondre, je t'ai dit ok, écoute, je te propose un truc, je te prends avec moi. On va à Bologne et puis on va dans l'usine Ducati. Alors, c'est exactement ce qu'on a fait. On est à Bologne, on est dans le musée Ducati qui est juste à côté de l'usine. Et puis, avec nous, on a Eduardo qui est un ancien journaliste et puis qui est spécialiste un peu, qui va nous expliquer cette évolution. Il travaille maintenant au département presse de chez Ducati. Je vais le faire en anglais. Hein? So yes, it's better for you. So Eduardo, thanks a lot for welcoming us in the museum and explaining everything about the GP bikes. So can you please introduce yourself?
Okay, well, first, thank you for coming here and welcome from Bologna. As you said before, I've been a journalist for 20 years for motorcycling in general. And starting, I think, the 1st of June, I'm actually a communication specialist for Ducati. So I'm here to answer all your questions as much as I can.
Yeah, no problem.
There is MotoGP has some very deep trade secrets, so I won't go into that much detail, but I think I can give you a good overview of the evolution of the technology from the first Ducati MotoGP here, you see the GP3, to all the latest ones in the one that won the World Championship a few weeks ago.
I just have one question before letting Julien ask his questions for his bachelor work. I know it's a big secret and most of people here could never pass this door. So could you once go inside the Ducati Corse office?
Yes, but I could not really look into that much detail as I wanted. Some areas were still restricted. Let's say that my badge doesn't open the door to Ducati Corse.
So it's a big secret here. So
yes.
Yeah, it's
Yes,
like
definitely.
a fortress.
There are two forbidden places here in Ducati for the general employees. Yep. One is Ducati Corse and the other is the Centro Stile.
Yeah. So where all the bikes are designed from sketch. So it's
you have to have a good reason to get there.
I hope we have one, but I think they would not accept that
we'll see.
No, not good enough. Okay, so I think we can start with the questions, and maybe Julien can start.
Donc Ducati arrive en 2002 dans le championnat du monde de MotoGP. D'autres concurrents, d'autres constructeurs y sont depuis 20-30 ans déjà. Quel a été l'élément déclencheur pour Ducati?
The main driver, the main reason why Ducati actually decided to race in MotoGP was the switch from 2 strokes to 4 strokes. Actually, Ducati wasn't interested in competing in the old, as we call it in Italian, Moto Mondiale, the old name of MotoGP, because as you know, 2 strokes had no production, actually, any development reason for production. So when the new regulation at the turn of the millennium actually came out, let's say the premier category, the premier class of motorcycling was to be 4 strokes. Ducati actually found very interesting racing there, both for promoting the image and for developing new solutions.
Donc Ducati Corse est créé en 1999. La première MotoGP de Ducati est entrée en 2003. Quel est le lien entre Ducati Corse et l'entrée de Ducati en MotoGP?
As you correctly said, Ducati Corse was founded actually as a separate company within the company in 1999. And a little fun fact, the CEO of Ducati Corse at that time was Claudio Domenicali. So now is the CEO of the Ducati. Yeah, exactly. And it was created basically to prepare, to build the factory, the worst Ducati superbikes to compete in the World Championship, and also to provide assistance to all the teams in the World Championship and in all national championships. The decision to compete in MotoGP was taken in 2001. So it actually, Ducati Corse, as you said, was already there. What basically Ducati did was to create a small structure inside Ducati, not so small structure, inside Ducati Corse that was led by engineer Preziosi. That designed the first MotoGP and had a separate unit that was, let's say, a self-standing unit led by Preziosi, and the other key figures in that were, of course, Claudio Domenicali and Livio Suppo, that later became the team manager of the first adventure of Ducati in MotoGP.
Donc, quel est l'intérêt d'un constructeur d'être en MotoGP? Est-ce que c'est une notion de prestige ou est-ce que c'est vraiment un laboratoire technologique?
It's a bit of both, because the MotoGP is the pinnacle of motorcycle racing. So it's the greatest test bench, stress test bench that you can have in the world for every kind of motorcycle. All the solutions that you develop in MotoGP can have a development into production motorcycles. So we'll talk about that later in detail, but most of the bikes that Ducati produce, many bikes in the Ducati lineup has something that has been developed in MotoGP. At the same time, it's a great promotional vehicle, mostly in emerging countries, in countries that don't know the name Ducati, but love MotoGP. They see a Ducati racing, they see a Ducati winning, hopefully, and they actually grow fond of the brand, and so it's also a great way of promoting your brand.
So we hope that you'll get even more clients next year as you won 2 titles this year. So if somebody didn't know about Ducati, now he does. So
yeah, they do.
It should be next year should be a good year.
Yeah.
Comment ont évolué les motos et la technologie sur les Ducati GP entre 2003 et 2022?
The evolution of the Ducati bikes, but of all MotoGP bikes, was basically driven by the regulations. For example, the first MotoGP, the first Desmo 16, was built in a place that you have to keep in mind that for almost, let's say, at least 30 years, there was no prototype category of racing in motorcycling. So everything was new for all the constructors. And there you see 3 cylinders, 4 cylinders, 5 cylinders, everything was new. And all the, not all, but most of the development efforts were concentrated on the engine. The first engines were built on the, let's say, on the experience of superbike racing. So with concepts, prototypal concepts, but still with a pretty close tie to production. We had many, let's say, room to experiment, to develop, and so on. So if you look at this is Loris Capitosi's first GP3, and you compare it to a modern MotoGP, there's 2 eras at least. In the first year, as I said, Ducati concentrated on the engine. The balance between horsepower and tractability was all to be explored. Tire was completely new, the chassis were completely new, and the engines were a bit of an unknown quantity. So there was much improvement to be found in developing the engine. Plus, it was exactly the period in which electronics were starting to make their appearances into the motorcycling world. They actually came out a bit into the two-stroke era, but they were pretty basic compared to what we have nowadays. For example, 2005 was the year in which the ride-by-wire was introduced, and that gave the way to the introduction of real tractions, light controls, wheelie controls, and things like that. The first systems were pretty rudimentary. It was around 2010, I think, with the 800s, where we could have tridimensional mappings for the throttle and many sophisticated systems. So at that time was pretty rough. But the biggest impulse to the development of electronics came actually with the 800s here. Because as you might recall, the regulation called for a substantial reduction in the fuel that was available to the motorcycle. So from 24 liters of the old 990s, the 800 started with 22, that became 21, and then 20. Efficiency and low consumption was the key to success. And this is the 2007 bike, the one with Casey Stoner, and you might remember the superiority of the engine in long straights. Ducati was extremely successful in implementing software strategies to control the consumption of the bike. If with 800s the team was, and the development was mostly concentrated on electronics, when the regulation changed again in 2012, as I remember, they introduced, 2011, and they introduced back the 1000 MotoGPs. They also introduced many control elements. The tire were controlled, they were Bridgestone first and then Michelin. And for example, the electronics later in 2016 were introduced as a single make, a control ECU, and then a control software. That meant that the development of the bikes could concentrate, and in the strategies, but not in the real development of the software itself. So the attention moved to the areas that were really gray areas, not really regulated, not blocked. So aerodynamics and chassis efficiency. For example, you started to see what were initially meant as whole shot devices, so devices that could lower the bike as to gain an advantage at the start of the race, and then become dynamic. So the lowering devices for the back, for example, are under control of the pilot that can use it whenever a strong acceleration is needed and can invoke it. So nowadays the development is mostly on aerodynamics and chassis. Electronics in the 800 era, and at the beginning it was mostly engine, mechanic development.
Donc en 2005, on instaure le ride-by-wire. Qu'est-ce que c'est finalement ce système électronique et que permet-il, surtout qu'aide-t-il au pilote?
So the ride-by-wire basically is the evolution, the transformation of the mechanical system, where you have on the accelerator, on the throttle, you have a pulley basically that opens the throttle bodies, and it's just mechanical, has no interjection of any electronic control, into a much more complex system where basically the accelerator isn't really connected to anything. It just, how can I say, a potentiometro in Italian. You just basically have a sensor that knows the position the accelerator is in, sends the signal to an ECU, to an electronic a computer, basically, that decides how much to open the throttle bodies and everything that surrounds it. That allows the engineers, the technicians, to control all the aspects of the engine behavior and performance. And as I said before, in the beginning, it was just a very basic system that actually allowed us to shut the throttles, the throttle bodies, or reduce the timing of the ignition. And with those two systems combined, you actually managed to modulate the power that was transmitted to the rear wheel from the engine, that was produced from the engine. Nowadays, the systems are much more sophisticated. Actually, you have 3D maps. That means that you have the throttle opening, the regime of the engine, and also the gear you're in, many parameters. So you can have a different degree of power and of torque delivered by the engine, calibrated specifically for every gear, for every regime, for every, basically for everything. And that allowed the engineers, the technician, to develop systems such as the traction control, the slide control, also the wheelie control, the engine brake control, everything that's related to everything, let's say, in the engine that influences the stability and the behavior of the vehicle or the motorcycle. The end result, to try to simplify that, is that the bike is easier to ride. We can actually make huge levels of power manageable from the rider. We can have bikes that are easier on the tires, they actually wear less of the tires. And in cases like we said before, when we had the 800, they had to run with very lean mixtures that have to be very efficient. You could actually avoid wasting fuel because if you have to correct a behavior of the bike, like changing the ignition, you have actually wasted some fuel in producing power that you don't really use. So the whole system is so efficient that when the pilot, the racer, the rider actually tries to accelerate, the system knows how much power can be transferred to the rear tire. So it's very efficient, it's easier to ride, it's less tiring from a physical point of view, and it can simplify the rider's work, let's say, and also at the same time being safer. Because when we didn't have electronics on the bikes, probably the most common dynamic you saw in accidents, in racing, were the so-called high side. When the rear tire skipped out, arrived at the edge of traction, and actually threw riders up the high side of the bike. If you see racing now, that phenomenon is very reduced because the system is so efficient that actually it can be really safe as a, how can you say, a production vehicle. but you can have systems that are very, very safe in maintaining stability of the vehicle, because that would slow the pilots down. It's not like they can just whack the throttle open and nothing happens. They get thrown to high heaven anyway, so if they do like that. But globally, the motorcycle is safer, even a racing motorcycle.
Donc, comme tu nous as expliqué, il y a pas mal de technologies. On sait que tu as expliqué ces fameuses maps. La question est, est-ce que les maps sont programmées à l'avance? Est-ce que chaque secteur possède une map? Est-ce que c'est activable par un pilote ou par l'extérieur? Qu'est-ce qui dirige tout ça?
First, there's been a change in regulations in 2016, as I remember correctly, that basically prohibited using GPS systems and so-called adaptive systems. So automatic systems that adapted to the condition of the race, to the progress of the race. So we can say that roughly everything or almost everything is under control of the rider. Let's make a step back. Every MotoGP and mostly every production bike nowadays have so-called ECU. So basically, a 6-axis accelerometers that control the, let's say, the status, the assetto, we could say in Italian, but actually the status of the bike. But also, it was developed actually for planes to know their position. It actually detected the status of the plane, but if you calculated all the movement the plane had, you actually could implement a basic rough autopilot. And it's more or less the same thing with bikes, because if you know where you start in the circuit, you actually know by calculating all the acceleration that the bike has, lateral and longitudinal and things like that, you actually can know where the bike is at the circuit. That means that the bike knows its place in space. And so it can implement different strategies for traction control, for wheel control, on different parts of the circuits, so corners and sections of the circuit. The thing is, every time that the bike passes, again, to the start-finish line, the system resets, knows that it's there, and it starts a new lap. That means that the bike doesn't know what lap it is in, but it does know where in the circuit is. So it can't auto-adapt its strategies to the consumption of the tires or the tank, like it was possible back in the past. But it can facilitate the life of the rider, of the racer, because he doesn't have to constantly switch the mappings for all the corners he wants to do it with. Everything, as I said, is operated by the rider in that way. All the lowering devices are mechanical, not electronical. It's forbidden by the rule book to have electronic systems like that. So it's actually Pecco Bagnaia. Actually, you see him activating some things on the handlebar, and that's probably some devices that lowers the front or the back of the bike. And the only communication that's allowed between the pit lane and the motorcycle is a message that can show up on the dashboard. It's not like in Formula One, you have a radio and also that the team knows how the bike is behaving and potential faults. There's no communication from the bike to the box.
Okay. So that's really interesting, because in Formula One they have the whole car under control. That means as soon as the rider leaves the box, it's like blackout. They just have the screens to see what the riders and the bikes
there's
are
no
doing,
connection.
But there's
they don't have anything on the screen. You see the technicians, when the pilot enters the pit lane, they're connecting the laptops. That's the only communication they have with the bike. They have no wireless systems.
Okay, so that's really interesting. So the rider is left alone for the whole race.
Exactly. It's not like in Formula One that the teams knows before the rider when a part is at a risk to break or something like that.
Okay. So now we are going to talk about one of the most visible aspects of these technologies that evolved on the GP bikes, and the most visible is winglets. So we are going to talk about aerodynamics, and I think you have somebody with us.
Most definitely. Let me introduce you Marco Nicotra. His job title actually is CFD coordinator. So basically, he knows everything about aerodynamics and the translation from the GP bikes to the production motorcycles, because as you know, aerodynamics are a big thing into production motorcycles now. I just start with a little bit of context, because you said correctly that in 2010, the first winglets appeared on a GP bikes. You can see here on the Nicky Hayden's bike, the GP10 was Nicky Hayden and Casey Stoner at that time, but they actually disappeared for a short while. The reason were two or manifold, because the thing is, the rule book was on the verge of switching from 800 to full-blown 1000cc GP bikes. So the development process concentrated on many other aspects at that time. Plus, as you might remember, Valentino Rossi suffered an injury to the shoulder the year before, so he didn't have his full strength. And at that time, the winglets were pretty rudimentary compared to what we have today. Marco will go into detail, required a little bit of effort to turn the bike in. So they preferred to remove it and to concentrate into other aspects. The winglets came back in 2015, I think, and I just let Marco talk because it's really his matter, his subject.
Yeah, so the winglets were then introduced back in 2015, and then we worked a lot to develop them. Here we can see the GP16 bike when the winglets reached the peak of evolution before limitations were introduced between the season 2016 and 2017. These wings here inspired the aerodynamics of the Superleggera bikes. And as I just said, a new set of rules were introduced between 2016 and 2017 season with the declared aim of increasing safety on track and at the same time keep cost under control. So we obviously faced a decrease in aerodynamic efficiency due to those new C-shape side-pod that we are forced to introduce. But then in the following years, we worked hard to recover, and now I can say we got back to a level of performance which is comparable to what we had before the limitations were introduced.
Alors en 2022, cette année, on a vu de nouvelles appendices aérodynamiques sur l'arrière des motos. Est-ce que tu peux nous en dire un petit peu plus à ce sujet?
Yeah, nowadays all bikes are pretty refined aerodynamically, so we really need to focus on detail to try and get some more performance. So, for instance, this year we focused on an area of the bike which is often considered not so aerodynamically efficient. I'm talking about detail of the bike because you know it's in the wake of the rider. But we introduced those fins that helped us adding some more rear downforce on the bike, which is particularly useful during braking and help the rider a little bit in that phase.
Est-ce que on pourrait voir dans un futur proche de nouvelles technologies au niveau des appendices aérodynamiques, notamment comme en Formule 1, on voit ce système d'aileron électronique. Est-ce que peut-être un jour, dans un futur, on pourrait voir ça sur une moto de compétition?
Active aerodynamics is explicitly prohibited by current technical regulation in MotoGP. As an aerodynamic engineer, I would love to exploit the potential of active wings on sport bikes, even if I doubt we could reach a considerable amount of drag reduction as it is, for example, in Formula 1 with the DRS, because of the limited size of the wings currently mounted on bikes.
Depuis quelques années, on voit apparaître sur des motos de série des éléments dérivés du monde de la compétition, notamment avec ces ailerons. Est-ce que vous pourrez nous dire un petit peu plus cette transition de la moto de compétition à la moto de série?
Well, one reason for us as a racing department to exist in a company like Ducati is to try and develop new technologies and then transfer them to production for road bikes. And this is especially important for aerodynamics. Ducati Corse is pretty much a R&D laboratory for Ducati, and the transfer of knowledge is constant and profitable for both. To give you an example, we developed the aerodynamics of the Panigale V4, taking advantage of years of aerodynamic studies applied to racing, and using the same simulation and data analysis tool that we developed over the years for the MotoGP application. This doesn't only apply to sport bike like the Panigale, but also to bikes that are not conceived for track usage, like for example the Multistrada V4, for which we used our cutting-edge simulation tools to guarantee the best possible thermal and aerodynamic comfort for the rider.
As Marco said, many technology, everything that we develop with Ducati Corse actually can find some reflection on our production bikes. For example, our V4s are strictly derived in many solutions like the counter-rotating crankshaft, but for example, even the bore measure is the same as the MotoGP, as is the same as in the Panigale. The engine of the Multistrada is still a V4 with a counter-rotating crankshaft. All the electronic systems actually benefit from all the studies, from the strategies and the application we have in MotoGP. So it's, as Marco said, it's actually more an R&D than a racing department. It actually serves both purposes. So everything in Ducati actually is born in racing and transferred to production.
So thank you both of you. Marco, thanks a lot. We'll let you go back to work. And I think with you, Eduardo, we are going to talk a little bit about the future of motorcycle.
On vient de parler d'électronique, d'aérodynamique. Maintenant, quelles sont les autres évolutions, innovations apportées de ces dernières années à la MotoGP?
During the 2003, almost 20 years, Ducati participated in MotoGP. It has introduced many innovations. Most of them, as I said before, I know I sound like a broken record, but it is like that. The development, everything you do on a MotoGP is mostly driven by regulations. So you actually try to exploit the best that you can within those regulations. For example, we tried on the 800s, Ducati also experimented a lot with chassis solutions. We tried to do things differently from all the others. For example, the Casey Stoner winning the World Championship winning bike was still with a steel frame that became aluminum monocoque and then carbon monocoque, and Ducati has been the first to introduce that kind of solution. It's been the same with the carbon swing arm. Those solutions did work at that time, mostly because there was no control tire rule. Because the thing is, you can go a different way from all the others if you have, in that case, for example, the tire manufacturer that follows you. And it can actually help you develop those solutions by providing a tire that works with your solution. If you have a control tire, the tire it's going to be something like one size fits all. So you probably have to be more conventional in that solution, and you have to explore other areas. For example, apart from those, Ducati also introduced for a brief period of time an electronically controlled clutch. For example, there's no need of that anymore. The engines has evolved, we have seamless shifts, so there's no need for that anymore. I don't know, aerodynamics, for example, the rear scoop actually deviates the flow of air towards the rear tire to keep it a bit fresher and perform everything. It's been introduced by Ducati. And most of those solutions are, let's say, Ducati introduced it or somebody else introduced it, and in the paddock everybody tries to do the same thing that the winning bike do. So, for example, the scoop has been, has been copied by everybody, almost everybody. It's been the same with the carbon swing arms. It's been the same with aerodynamics. You see that the solutions, once they become effective, everybody moves towards mostly the same road. So basically it's like that.
I have a complementary question. Sometimes you have a new innovation that comes. Is it, for example, Ducati who ask the suppliers, for example, for the ECU, for the forks, for the brakes, to adapt to some new ideas that you could have, or are the suppliers sometimes creating something new and come to see you and say, hey, we have a new technology that you could use for the race? How does it work?
I'd say it's a bit of both. For example, the braking components and the suspension is mostly the same for everybody, because there's, I think, I don't know if all the grid this year, but roughly all the grid is uses Brembo brakes and only suspension. So basically the kit is the same, is available to everybody. When they bring an innovation, it's almost available to everybody. And we might develop our bike around the new technology, the new solution, the new, for example, if we have more braking power, for example, with the new brake components and things like that, all the bike has to be developed as to exploit the best they can that solution. So engine braking, so the geometry of the bike and everything else. For other developments, it might have Ducati Corse might find a need, an area of improvement, and it requires, for example, determinate solution of, I don't know, structure of carbon fiber. So it works with the supplier to have that kind of product to implement in the MotoGP. So sometimes it's state-of-the-art driven, sometimes it's Ducati Corse driven.
Okay, and when you have a new innovation created by Ducati, do you have to give it to the others so the level can be the same, or can you keep it, or how does it, like you create something really new, really innovative, like you said, the scoop, and I think with the scoop everybody was not happy with that at the beginning because they thought it would be one more aerodynamic element.
In the MotoGP, everything that you cannot see is kept as secret as is possible.
Okay.
You never see a MotoGP without the fairings, for example.
Yeah. Okay.
You see,
right.
So everything that goes on under the fairings is strictly secret. So we try our best, Ducati tries its best to keep their secret, their competitive advantage for the competitors. Sometimes even aerodynamics is clearly visible, so you cannot really keep it that. So
it's hard, yes.
You have a small advantage for maybe a few races up until the competitors homologate the same fairing profiles for their bike, and then you lose that advantage.
So you create a new fairing or anything, or aerodynamic elements, who needs to homologate that? So you need to go to the FIM to...
The thing is, the regulation is, I think that currently you can have 2 different profiles per year. So there's the bike that you start the year with, and you can have a different profile for fairings and aerodynamic appendixes, winglets and things like that you can homologate, and you have to declare to the to Dorna and FIM, to the federation, that you have a new profile. Their technical advisors analyze the profile, and if it complies with the rule, then it's that.
Okay.
On voit chez Ducati des pilotes usines, des pilotes satellites. Profitent-ils de la même technologie au même temps, ou cela diffère?
Okay, there's no straight answer to that question. The thing is, it's all a matter of agreements between the factory and the single teams. I can tell you, for example, that the situation this year has been that the Ducati Lenovo team was the factory team, had obviously the official bikes, the factory bikes, and also the right to, let's say, to guide the development. So just Jack and Pecco were listened when the technician, when Ducati Corse had to choose in which direction, which components work and which didn't. Pramac, for example, is a satellite team. They have the same material at the start of the year, and they most of the times get the same technology, the same developments of the factory riders, but not at the same time. the Ducati concentrates on the factory pilots, the factory team, and then roughly after, I don't know, there's no real rule, but after 2, 3, 4 races, the same material can become available to the other. Some of the pilots, like Marco Bezzecchi, for example, that was rookie, never had the 2022 bike. It had the 2021, basically last year bikes, with sometimes some of the evolution if they fit, because basically you have to keep in mind that the MotoGP is a full prototype. It's not the same bike every year. Sometimes they change totally. So sometimes, most of the times, the particulars that fit on the GP22, for example, don't really fit on the 21. The fairings, tank, seat area, components in the engine, and things like that. So basically, the difference between a satellite team, like the Pramac team, or a satellite rider, and the factory rider is that the factory rider decides what works and what doesn't. So the development is guided by the factory riders. The satellite team has the same material, but they don't have it at the same time, and they have most of the time they have no voice in deciding what's the development direction. Also, there might be, for example, Ducati has a test team led by Michele Pirro, that the guy who works the most things. So they pre-test the components that go towards the factory bikes, and sometimes when you have a very close relation with the team, like with Pramac, if you really need to collect as much data as you can on a particular, you actually give them at the same time as the factory team, because you collect as more data as you can. So as I said, there's basically no rule. It depends on agreements and situation.
So you said that, for example, this year, Pecco and Jack were the only one that the factory would listen to. Mm-hmm. To what extent they are part of the development of the bikes?
They are fundamental.
This is interesting. This is not just somebody who's talented that you put on the bike, which is ready to ride.
No, the thing is basically the engineers decide what they need. Analyzing the data from the season, the engineers in Ducati Corsa decide we have to go in that direction. Then there's Michele Pirro and the test team. It actually works through the most of the solution to find out what works and what doesn't. Michele is very fast and talented riders, but the tiny gap that there is between Michele Pirro and Pecco and Jack this year is decisive in a race. You see that in MotoGP the races are very close. So even if Michele Pirro says let's say these 3 frames work, they have to be selected by Pecco and Jack. There might be this works, this doesn't, or let's go back to the drawing board and things like that. I don't really like to say, it's not that they said anything wrong, but I don't really like to say that Ducati doesn't listen to others. Yeah. The thing is, you can't listen to everybody, because the bikes, you can't really develop 8 different bikes on the grid. So the guys have the privilege to decide in which direction the development effort goes, and you have to follow that. But as I said before, if you really need to collect data from all 8 riders, you give the same bike to all 8 riders, and you give the same details to all of them, and you listen to all of them, because all input is precious.
Est-ce que dans un futur proche, on pourrait voir de nouvelles règles apparaître, notamment avec cette question de l'écologie dans le monde de la compétition? Qu'est-ce que tu en penses?
Let's say we're not scared. We don't know what the future will be, but as you might know, the regulations in MotoGP are always thinking that way. MotoGP will use like clean fuel, like biofuel, from I think 2024 for the 50% of the whole mass of the fuel, and from 2026 it only will have so-called synthetic fuels. So no more gasoline as we know now. On the other hand, as you know, Ducati from next year will be the sole supplier for the Moto E World Cup with our prototype that's been built for zero emission, clean electrical vehicle. So we're ready for whatever the future will bring to us. Basically, the position of Ducati right now is to be prepared for everything, to collect experience, collect expertise, and develop all the solutions at the best of our possibilities to be ready to confront with whatever the future will bring us. We still don't know if it will be biofuels or electric or any other solutions. So we try to be ready.
So Eduardo, thanks a lot for all this information. That was really super interesting. And yeah, I think we have everything. You answered all his questions. Thanks a lot.
Yes,
No.
thank you.
And see you at the party tonight.
Definitely.
Thanks. Thank you.
No, thank you, and you're welcome.
Signore e signori, campione del mondo 2022 della classe regina, la Desmo 16 GP! Con il numero 63, il campione del mondo MotoGP, Francesco Pecco Bagnaia!